Okay, this one's not as fun as Troy's. It's a little bit dry. So, and it's also pretty much just standard stuff. So, feel free to add in, chip in and tell us how it's going, what you think of the various things as we go through. But it's probably one that's useful because I think in a lot of cases, F#, if it does start to appear, won't appear on its own. It's going to have to interoperate with other projects. So, C# not always the best language. That's sort of an assumption it is, but I don't believe that. That was off a ThoughtWorks document from a couple of years ago. I think it's fairly true. Excellent, concisely expressing business and domain logic. Developers trying to achieve explicit business logic with an application may opt to express their domain logic in F# with the plumbing in C#, UI, whatever. I would tend to think that might be a bit of a sweet spot in the short term for F# in the business sort of area, is the actual expression of business rules and that sort of thing. Whereas, it's probably going to be hard to get stuff like MVC out of the standard paradigm that's well established. Equational reasoning. These are some of the things I think give it an advantage. Because there's no side effects, it's easy to reason about the code and what it's going to produce. And if you're talking about business rules, that makes it a lot easier to say this will happen during the evaluation of these rules. You can sit down and you can desk check or whatever. And you can be pretty sure of what you see. It's a desirable property of code for business property and rules. I think also on unit testing in OO languages tends to get fairly involved. And I think, to me, unit testing is simpler in F#. It has less overhead. A function has its own interface. Dependencies are composed in a natural manner. Records instruction comparison is easily done. So unit testing in FP tends not to have a big impact on the design of the code. So there you've got the standard internet meme, add some F# into your C#. And a little bit of a quote from John Carmack on that sometimes simpler is better. So if you're in C#, how does F# look? You can just call an F# function defined in a module, and that's easy. Records can work in C#, and we know that there's work going on there. But that starts to get a bit messy after a while. Inevitably you have parameters and so on, so you want to get it all a bit tidier. So generally an F# type in a namespace is a better way to do an API, unless it's something really quick and dirty. If it's quick and dirty, modules become a static class. The resize array is just an alias for the standard C# list. So if you need to go backwards and forwards, that can ease that a little bit. In the C# project, you can add a reference to the C# core if you need to deal with F# specific types. Recognise when it's time, when this is all getting a little bit messy, and then it's probably time to have a proper API, which is probably fairly early on in the piece. Records can work fairly well in C#. This is from the component design guidelines on interops. So a record declared on the top, and will just appear as a C# class with some read-only properties. The no equality, no comparison is just to suppress interfaces that F# would normally generate. There's no big deal about it. You can leave them there. You can take them out. You know, if they're a bit surprising to C# developers, you can remove them. Mutable record fields become a public field. So records are pretty straightforward. Now, to do it properly in API, put an F# class in a namespace, and I tend to like this sort of pattern myself, where you start off with your type declaration, your record whatever, then you have a module with your functions that operate on that type. Your unit tests come in at this level, and then below that you can then use an extension to the type. You can reopen the type and add members to it, and those members can delegate to that. So these members will then expose themselves out to C# in an idiomatic manner. That's an intrinsic type extension, which seems a fairly complex way of describing it. It has to be in the same file. Okay, so as I say, I've just stolen it all, so there's no particular talent of my own there. Feel free to take some of the load off me by adding some comments or some cat calls in or anything. Alright, so for anything reasonable, this is the sort of recommended way. And here we've got an example, and what this little example is trying to get at is one of the things you get from this way is you can use operator overloading, which is not otherwise available. So you can get, you know, if at a later stage you come along and you realise you need a slight variant on that, you can introduce it. And what about all the little bits and pieces? Unions. Well, unions aren't going to appear nicely over in C# at this stage. So generally, you're going to have to expose some sort of members to manipulate those if that's required. So, for instance, a static member there, which is producing the discriminated union case, and a instance one to do some operation on it.
So, Brendan, the signature file, what does that do for us?
Okay. A signature file will control access. So if a signature file is present, it takes precedence in controlling access and how the API is seen. I've never bothered using them. Does anyone use signature files? No, but I do know that a signature file, if it's present, takes precedence. Okay. And so you know how the standard thing with F# where you get, you know, the signature of, you know, type, arrow, arrow till you finally get to the end of it. Yeah. If there's a signature file, and I can't remember the extension for the signature file, it's the same name, a slightly different extension. If that's present, that just takes total precedence over what's actually in the code file as far as exposing an API goes. And so
so that would take precedence even for other F# stuff calling it?
Yeah.
Right.
Yeah.
Okay.
Yeah. F# events are not standard, because we sort of know, because standard events aren't composable. So F-sharp events are a simpler sort of form of event. But that can be a bit troublesome from a different language. Okay, so we have the CLI event attribute to say that you want to work with standard.NET events. The recommendation, don't use F-sharp events from C#. And we're well used to this from C# and things like this, just derive from event args. Okay, and then make a delegate instance, okay, make up your type and expose it. It's probably a little bit messy, but you know, I don't know that there's a good way around that.
Yeah, and I guess the whole idea is because this is a case in which you are going to expose your F# code to C#, you are not going to do this inside your nice F# code. You are going to put this like a wrapper around your F# API. So then whoever is calling this from C# has something that is familiar to them. It's an object-oriented API that they know how to call with events.
George has expressed it perfectly. Yeah, that's it. So you're trying to think in the C# terms. F# async isn't standard. Now, we've got a traditional API. F# ACI, async computation can be exposed using the AIS, the old, you know, the going back to the very early days, begin and end. Okay, so, and so async as begin end is sort of the core of that. So we can pretty much, while there seems to be a bit of code there, it really is pretty much boilerplate.
So sorry, as begin end, that then is
that produces this set of actions.
Yeah, okay, I've got you. So it returns a
well, these are then
tuple.
exposed through these members.
Yeah. Okay.
So they're produced out of that and then exposed out of these. Remember the style we were saying of, you know, do your stuff in the middle and expose it in members underneath.
Yeah.
Okay. So the first one is the one that really has the code that you want to run. The first line, the compute one. That's the actual function that you want to run, and then you expose the begin, end, and cancel actions from that compute.
Yeah.
Okay. You generate that in the second and third line, and then you expose it in the next one.
Yeah, well, that one's really just wrapping it and so on, but that's it. The first one is the nuts of what you want. That's the canary that's providing you the...
to split the...
That's right.
And then you're exposing them out as three separate methods.
And but that doesn't return tasks, does it?
No. So that's the next one. So this is pre-task sort of thing.
Older way.
Yeah. Cool. So hence, you know, traditional older might have been better.
But you could, task has a factory method to handle these cases.
Yeah.
So you could, from the C# code, wrap this into...
Oh yeah. So that's as you said, largely the point is to make it sort of transparent to use from C#, and it's only for the actual API. So here we go where we do have tasks. So computers task, and that takes us to a somewhat newer form of doing it.
Okay. So this is another way of doing it.
Yeah. Both give the
Okay.
both skin the same cat, but this is the newer task-based one.
So that's the task. Cool.
Does it matter which C#
language you're targeting? Like with .NET framework, you want to expose your code to, you write it accordingly?
Well, only to the extent that something like this, I think, what was it, version 4?
Right.
I think.
Yeah.
And I would imagine, I don't know the answer to that in terms of 4 and 3 running together, but I think different modules from 4 and 3 will run together, won't they?
Yeah, and you have a task parallel library for previous version of .NET, but I'm not sure how this works with this, because this, if you target 2 different .NET frameworks, this is not going to work nicely. So
yeah, I'll defer to George because I'm not sure there. But actually, I don't know, does anyone much still work with actually writing code in earlier than 4? Yeah? Okay.
2.0 and come back.
Oh, okay.
Not good.
That wasn't sort of a put down or anything. It was just that it seems to have been out for a while now. It feels like it's been a while.
yeah, it
Yeah.
Some companies still using Windows mobiles for God knows what reason.
Yeah.
It's like all just with big companies.
Yeah.
They get OEM devices and stuff.
Yeah, so you're stuck with because of the hardware. Yeah. Okay, another thing that's not standard, functions. So if you simply, if you're passing a function as a first-class value, it'll show up in C# as an F# function, which or F# func, which is probably a bit unfriendly. So for recent systems, use the standard delegates and just wrap them, and most people are fairly used to using those by now. They sort of seem to crop up a fair bit these days. I didn't bother putting anything in for earlier ones because, I'm sorry, I just didn't think it came up very much these days. Easy to place the implementation of higher order functions. I think use the delegate wrapped F# higher order function from F#, use the raw from F#, don't use a C# higher order function. So in other words, stick the stuff in F#. To me that's a bit of a truism anyway. Stick your logic in F#, stick your business rules or whatever in F#, and that's probably where your higher order functions are going to get evaluated anyway. And that's one of the recommendations anyway. Don't do it the other way around. It tends not to work so well. Options aren't standard either at this stage. And this is all how not to have to put the F# code and the references and the funny F# stuff in. So the recommendation is you can use the try-get pattern to give a C# friendly form of a option. So that your C# programmer will see something they're familiar with and know that it might fail. Use method overloading to pass in options as arguments. So instead of doing what we do in F# of just putting an optional thing on the end, take the advantage of the method overloading. So one of the cases of method overloading useful in the API is for extending at a later stage. Another one is where you may have optional arguments. So expose that to C# as an overload rather than as an option.
Do you know if it is possible to return as a nullable, let's say, integer, the option? Because I tried the other way around, so converting a nullable to an option, but
I've got a vague feeling in the back of my mind I've tried it and it didn't sort of flow easily.
cool.
So no, I don't know the answer, but superficially you think they're very much the same thing, don't you?
Yeah, especially for primitive types.
Yeah.
It won't work for a reference type.
Well, one of the problems with options is options don't have to be values. I know what you're saying, and it seems attractive. I can't tell you why it's never worked for me. Not that I've tried it a great deal, but it didn't flow for me, whatever it was. But, that...
Yeah, try that.
I suppose the part with option, and I guess this is the same for a nullable, is you're trying to get across the idea of failure
Yeah.
or not being there.
Yeah.
But for whatever reason, and that's given us that's the recommended. I'm not sure how easy it is to use nullable in F#. Do you have to do something special to use them?
You can't do the question mark, you've actually got a nullable.
Yeah.
It's like variable both.
It is like nullable and then type and then kind of passing.
Yeah, use an underscore for the type, I guess, for just support all the types.
Yeah.
Yeah.
But it's verbose.
Yeah.
There's no nice sugar.
Yeah, and maybe it just feels a bit unnatural or something. Lists aren't standard. The general recommendation is try and put things over sequences, so that, you know, to sequence or something, so you've got enumerables, because everyone can consume an enumerable. Or to a by dictionary, you know, key value. You know, if you have a list, for instance, turn it into a sequence or something like that, and that exposes very well. You can use a resize array, but internally it's probably doing just as much work. Yeah, as in any sort of .NET programming, you know, arrays or, you know, more performance efficient structures can be used if you need them. Okay, and we've mentioned the resize array. I think it's more of a quick and dirty thing, but there we go. Okay. All right, keep out nulls. So if you're taking parameters, just make sure no one's passing you null. I suppose that's a bit of a motherhood statement for any code. So there's an example of a little, you know, function that will just do, you know, what do you call them, the pegs or whatever, I forget what it is, but you know, the assertions at the top of the function. Yeah, guards, code contracts, yeah, something like that. So anyway, that's a little sort of motherhood that goes for most APIs. It's amazing back in the day when the MFC libraries came out for Windows, how much the stability of Windows programs improved, because the MFC libraries had a lot of guard code at the top of functions. They almost then immediately called it a Windows, but they added all the guard code that wasn't there in the old Windows, which was very lean, and the stability of Windows programs just went forward. Keep functions bland, a little bit of a pun there. You can, if you're not used to it, you can inadvertently curry things. So of course, you know, we're all aware that that is not function brackets, that since everything is a function in C#, that doesn't mean a function. It means tuple. So that's having a tupled argument passed to it. Now, by contrast, that one is having a carried argument passed to it, where each one is at least theoretically evaluated in turn. And so the recommendation is for an API going to C, use a tupled argument. So.
Yeah, and you see that in some of the BCL libraries when you use it from F#.
Yeah.
You actually need to pass a tuple to them many times.
Yeah. I mean, it's pretty straightforward once you sort of go click, oh yeah. But otherwise a bit strange, because, you know, F# will want to do the first then the second, you know, and want to treat them, you know, as you would expect F# to, which will look a bit strange to a C# programmer. A bit of an example there. So, what are the things that might be done to improve that? So, nothing greatly wrong with it, but first off, returning a list isn't very friendly. So, change it to return a sequence. Okay, and the walk member, which takes a higher order function, change that over to wrap into a standard .NET, delegate type. And that's about it on that. I mean, hopefully it gets even easier with the next version of C#. But I thought since we had to use grep, maybe some of those might be interesting points, or you might have your own. For instance, is that a reasonable way to use F#?
I tried to, so as a proof of concept for one of our applications, we had like a very complex logic that was like mostly about calculations. What I felt is that, okay, this is a very good fit for F#, and I actually did a proof of concept of writing that in F# and then exposing that to C#.
Mm-hmm.
So the code was obviously reduced and more compact and easier to follow for an F# programmer. Obviously, my other colleagues were not happy, but but I kind of felt that pain that when I was trying to use it from C#, actually the functions are exposed using another types and the high order functions and so on. So
and that also causes a bit of pushback from the C# programmers, because they see this stuff and they go, "What's that?"
Yeah.
Yeah.
And you don't see it when you program in the functional way. You tend to use functions, and they are not an instance method of a class. They are just functions, and by default, because they are part of a module, they are static. So if you are using in object-oriented programming and IOC container and so on, then now you want to plug your new F# DLL or API using the same mechanism, and that's where static doesn't really work that way. If you want to inject it and be able to test it, plug in a mock or something like that. So that's where it's handy just to create a class in F# that exposes methods and everything as you would expect in C#, and then that is going to call all the static functions and all the functionality.
Yeah.
And that worked for me, at least for that piece of work.
Yeah, that was, I think that's a bit like that thing with the 3 parts, your basic type, your module with your operations, and then whatever you expose as an extension.
Yeah, I think it has its limits, but if you can work within that, then it's well worth it.
Yeah.
I find that once you get the API set up, what I find is that I've now done what I should have done in C# anyway, which is write a really nice API and put the time into it, and then have everything in the background.
Because you do get a nice API.
Yeah, that's right. There are some things that you have to watch, like you can't inherit two things. You can only inherit one class.
But everyone knows inheritance is evil.
Well, that is true, but if your C# code is expecting you to implement, like, this interface and this interface, like you might have implement something as well as nullable or something like that, then you're going to be in trouble.
Yeah.
But if you, like as an example, if you don't need that, then it's well worth it.
And well, to me, what I like about it is I find it's just so much easier to test F# code.
Yeah, especially using the F# interactive, the repo. It's like, you just write the function, you send it to the interactive, and you try. And we tend in C# I tend to write unit tests for that to really see how that function or method behaves.
It just works well, doesn't it? Yeah.
It's another way of writing code.
Yeah.
For sure. Well, thank you very much.
Thank you.